Hey everyone, just to let you know, I just finished grading AP Physics 1 exam number 4. Now I'm going to go over each and every problem. Now, before I get started, I just wanted to remind you that we're going to have Einstein Competition 1 on November 5, Wednesday, and Einstein Competition 2 on November 7, Friday. If you win one of those competitions, I will uh, adjusted your quiz, all 4 quiz, and all exams to 100. So study exam 4 and pay attention to this tutorial. If you understand everything on this I cover on this tutorial, then you have a high chance of winning at least one of the Einstein competitions. Number 1, AP exam 4 is very easy. I gave you 4 scenario, 4 ball. You should be able to imagine 4 ball hitting the ground, which one touch the ground fast and which one also touch the ground with highest impact speed. Okay, so you should create a table 60, 100, 60, 60. And then you should write initial velocity, all initial velocity at the y direction, because the time depend on y direction. X direction you don't care, because X direction do not contribute to the time. Y direction contribute to the time. So you just write down what's going on at the y direction. Y direction, while you are throwing it up with what? With with 25 meter per second. So this is 90 degree. Throwing off means 90 degree. Nothing is going on at the x direction. This one you're just dropping. Dropping means initial velocity at the y direction is 0. This one dropping means 270 degree. Okay. Okay. So now this one, this is dropping, and this is throwing down with negative 20, or you can say, instead of writing negative, you can say 270. And this one also throwing down, this one 30 sine 30, okay, which is 30 sine 30, which is 15. You can say negative 15, okay, or you can say 15, well, yeah, sure, or 15 270. Okay, those ideas are the same. So which one is the usual suspect? You only do the usual suspect. Is this a usual suspect? No. What is the usual suspect for what? Which one? You should able to see. You close your eye, and you should see 4 ball approaching to the ground. Which one will touch the ground before other 3 ball? Okay, if you do that, then the usual suspect should be these two. However, scenario C is our suspect because they both fall from the same height. But this one falling with a negative 20, this one with falling with negative 15. But the slope going to be the same, right? The slope of velocity is acceleration with the same acceleration. So this one would be touching the ground before anything. So we only going to investigate this one. This one will have the highest impact speed. So this is our suspect for question number 2. This is our suspect for question number 1. D is 60. Initial velocity is negative 20t minus 5t squared. So you have 5t squared. This is negative 20. So positive 20t minus 60 is equal to 0. So t squared, you divide everything by 4, plus 5t minus 12 is equal to 0. So you do quadratic formula. So you write minus 5 plus minus 25 plus 48 divided by 2. T is equal to about 2 seconds. So this takes t is equal to about 2.3 seconds. So you can use the same way, same quadratic formula to find the other time. So absolutely this one is the winner because 2 seconds means this one will hit the ground before other balls. So ball C will hit the ground before ball A, B, and D. Now we're going to see which one going to create more impact on the ground. Our suspect is So impact velocity, velocity impact. So our suspect is the D. Impact means, okay, so you're throwing the ball. This is ball D, right? Throwing it down. So the ball D has two components. One is Vx, which is 26. One is Vy, which we're going to find it out now. So Vf is equal to Vi plus At. Vi is, of course, negative 15 minus 10. It falls for how long? It falls for 2.3 seconds, 2.3. So negative 15 minus 23. So 8, 3, 38, negative 38. So this one is negative 38. So we're going to find the speed by using head and tail. So you're going to draw the Vx vector. Okay, Vx vector. You're going to find the head of the Vx vector and put the tail of Vy vector. Okay, now we're going to draw the resultant. This is the resultant. Okay, so this one is 26. This one is a negative 38. Since arrow is here, you don't have to write a negative. So you do the Pythagorean theorem. So 38 squared plus 26 squared, and that is 46. So this one is 46. So you're going to write 46 over here. 46 meter per second. Impact velocity for this one, 46 meter per second, right? And what direction? Okay, let's find the direction. Tangent theta is tan inverse 38 divided by 26. Don't forget negative 38. So tangent negative 38 divided by 26, and that is negative 55 degree. So you want to write this is negative 55 degree. So 360 minus 55. So 305. 46 meter per second, 305 degree. Impact speed. Impact. So who is the winner for question number A? Ball C. Who is the winner for question number B? Ball D. Okay, so the problem is simple, but I took my time to explain it. I'm going to also explain something else you're probably going to see in Einstein competition. Okay, this is, we're going to say ball A. This is ball A. This is, you're going to say ball B. Ball B. Ball B is not 5 seconds actually. Ball B is square root of 20. Square root of 20 is not 5, 4.4. Ball B. We're gonna say ball B starts 60. No, ball B 100 and 4.4 right here. All right. Ball D 2.3 second. 2.3 second. 2.3 second. Okay. So this is ball A, this is ball B, this is ball C, this is ball D. So our problem number 2, which is the easiest problem in the test if you did pay attention to the class when we solved it the other day. The prereq to understand this problem is you have to have a good understanding with vector addition and vector subtraction and relative velocity. Let me cover everything before I solve the problem number 2. Okay, so now I'm going to only do vector subtraction and relative velocity. Okay, now let's see the scenario. This is north, this is south, this is west, this is east. This is the river. Okay, so the same thing, north and south. The distance d, which is 110 meters, doesn't really matter. Okay, now let's consider a few swimmers, and we're gonna rank. We're gonna have like 10 swimmers and see which swimmer take least amount of time. Rank, angle, and the time. Because we're gonna understand why some swimmer can get to the other side faster than the other swimmer. This is swimmer number 1. This is Johnny start, and this is the dock. Swimmer number 1. Swimmer number 1. Swimmer number 1, and then swimmer number 2. I'm gonna say 180 degree. I'm gonna say 180 degree, 150, 135, 120, 90, 60, 45, 30, and 0. Okay, the rank number 1 is 90 degree. Time gonna take 60 seconds. If the velocity initial is 1.85 of the boat and velocity of the river is 1.2 meter per second. The problem that we solved did in the test, because Vx is 0. Okay, rank 2, 60 degree and 120. So 60 and 120, they are the same. 60 and 120, they are the same. 70 seconds. Vx is little small. Vx doesn't exist here. Vx is 0. So there is no Vx. So Vx is small. Rank 3, 135 and 45. So 45 and 135. 84. Big Bx. Rank 4, 150 and 30. 150. 120. Big Vx. And then finally 0 and 180. They never get to the other side. 0 and 120 never get to the 180 never get to the other side. So forget about this, because they don't have Vy. If you don't have Vy, you don't get to the other side. So okay, I'm gonna keep this one. In the test, I give you 3 scenarios. Scenario 1, scenario 2, scenario 3. Scenario 1, the distance from here to here is 110 meter. 110 meter. 110 meters. Velocity of boat is velocity of the river is 1.2 meter per second. Velocity of boat. No, velocity of the river is 1.2 meter per second. Velocity of the river is 1.2 meter per second. Velocity of the river is 1.2 meter per second. The velocity of the boat is the same, but angle is not. So the angle is 90 degree over here. So this is velocity of the boat, which is 1.85. This is unknown angle. I'm going to write the angle. Angle is 90. Angle is unknown. I'll write the angle over here. Angle is 75 given. So this is 1.85. Velocity of the boat. Velocity of the boat, 1.85. Okay. Now, what else are you going to do? You're going to do, there is no, okay, so this is velocity of the river, which is 1.2, and this is the total velocity, which is square root of this. The square root of 1.2 square, 1.2 square. This is right angle triangle. 1.85 square. 2.2. So this is 2.2. This is how much? I'm using same color. Okay, I don't know why, but this is, there is a vector subtraction over here. So 1 point square root of 1.85 square minus 1.2 square, and that is 1.4. So this is 1.4, and this is right. This is right angle triangle. This is right angle triangle. However, this is a scalene triangle. Why this is a scalene triangle? Because all 3 sides are not same. So this is 1.2, and we are trying to find this one. So you're going to draw a parallelogram. So I'm going to draw this one, and I'm going to draw the other one. So scaling, we're going to use the, so this is the resultant, and this is 75 degrees. So we're going to use law of parallelogram. R squared is equal to a squared plus b squared plus 2ab cosine 75. Okay, so this is 75. Okay, now let's find this angle. So sine opposite 1.2 divided by 1.85, and that is 40 plus 90, 130. So now we know which one is now let's rank it. This one gonna take forever. Let me see which one Vx is bigger. This one Vx is, let's find Vx over here, then we can, this is Vx is 0, Vy is 1.85. This is Vx, Vy. This is Vx, Vy. Once we have Vx, Vy, we can make a hypothesis using this. Again, everything you should be able to see in fraction of a second. That's the beauty of it. Once you have a full understanding, this is just in your brain. Okay. All right. So what is Vxy? Vx. So 1.85 cosine 130. 1.85 sine 130, and that is negative 1.2 and 1.4. Negative 1.2 and 1.4. So this is U's. Let's find this one. V, A and B, AX, AY, BX, BY. BX is 1.2, BY is 0. AX is 1.85 cosine 75. 1.85 cosine 75, which is 1.85 cosine 75, which is 0.5. 0.5. 1.85 sine 75, which is 1.8. So this is 0.5. This is 1.8. Okay, so we're gonna make hypothesis now. This is V. So what is the biggest Vx? This is the biggest. Of course, I'm taking absolute value. So scenario 2 gonna take forever, and then scenario 3, and then scenario 1, because this Vx is biggest, this Vx is second biggest, this Vx is 0. No Vx over here. Okay, now let's see whether that's true. Let's see how long this one gonna take. T is equal to d over Vy. 110 divided by Vy is how much? 1.85. Now let's do this one. T is equal to d over Vy. So d is 110 and Vy is how much? Scenario 2, 1.4. T is equal to d over Vy. So T is equal to d is how much? 110, and Vy is 1.8. Okay, so now let's go ahead and do that. So 110 divided by 1.85, 110 divided by 1.4, 110 divided by 1.8, 60, 78, 61. Right here. Find out how far. So this is downstream. So this is waterfall, waterfall, waterfall. So how far downstream this swimmer gonna be? So downstream dx is equal to vxt. Vx is 1.2 times 60. B is 60. B is how far the downstream that guy ended up. So vxt is like a range. Vx is how much? 1.2 and t is 60. 1.2 times 60. 1.2 times 60. I should be able to know it without what angle this guy has to move. So he ended up at the dock. So 130 degree. This one will take, as we said, 78 seconds. 75 degree. Now we have to find the boat velocity relative to the shore. So now we're going to use the parallelogram. So if we do use the parallelogram, what do we get? A squared is how much? 1.2 squared plus b squared 1.85 squared plus 2 1.2 1.85 cosine 75. Of course there are other way of doing it, but this is one of the way. There are 20 ways. I think I show you 10 ways. Plus 1.85 squared plus 2 times 1.2 times 1.85 cosine 75, and that gives you 2.45. Find out how long does it take. We already found it. 110 divided by 1.8, and that is 61 second. So yeah, problem number 2 is not difficult at all. Now let's go over problem number 3, which is probably the easiest problem in the test. I gave you 3 vectors. This is vector addition. The last one was vector subtraction, relative velocity, and this one is vector addition. I give you 3 vectors, right? Vector 1 is 620 at 0 degree, vector 2 is 440 at 45 degree, and then 550 at 53 degree, and it should not take you more than 2 minutes to solve this problem. Problem has a 3-part, and this shouldn't take you more than 3 minutes to solve this problem. You'll see. 1 centimeter is 200 kilometer, I said. Okay, that doesn't matter because I'm not going to do it to the scale because I don't have the ruler and protractor with me right now. This is 620, and this is vector A, which is 620 kilometer. Vector B is 45 degree. Remember, this is north, this is south, and this is east, this is west. So I ask you to go to 45 degree southeast. So this is X. So 45 degree southeast means this. Okay, so this is 45 degree southeast. Okay, 45 degree. And that vector is 440. And then I ask you to go to 53 degree southwest. So 53 degrees, so you have an x-axis, 53 degree, and go to southwest, 53 degree. So 53 degrees southwest, right? So how are you going to do that? It's 45 degree. This is x-axis, so this is 53 degree. 53 degree. 53 degree. Okay. So again, I'm not drawing to the scale. So this is your x-axis, and this is 53 degree. And C is 550 kilometer. Everything is kilometer. All right, now this is your resultant angle. This is your resultant angle. this is your resultant, and this is your resultant angle. Okay, if you some of you give me this one, I accept it. I'm very flexible. I'm very flexible. Okay, so vector, as I said, this is probably the easiest problem in the test. A, B, and C. AX, AY, BX, BY, CX, CY. 620 cosine 0, 620 sine 0. So I'm going to say this is 620, this is 0. 440 cosine, look, 440, this is 440. So we're going to take this one. So 360 minus 45, only God knows. 360 minus 45, and that is 315. 440 sine 315. Now let's do this one. So to do this, this is the vector. So 180 plus 53, 180 plus 53, and that is 233. So 550 cosine 233, 550 sine 233. As you see, this takes if you don't have to write those things down, this takes exactly 3 minutes. So 440, and you use the law of parallelogram or law of cosine, it takes 1 minute. 440 cosine 315, 440 sine 315, 550 cosine 233, 550 sine 233. I have everything I need. I'm gonna just copy it. 311, negative 311, because this is 45 degrees, the same thing. Negative 331, negative 439. Hopefully this is right. Sure. But understand that this C looks right, because C gonna end up in third quadrant. Third quadrant, both of them is negative. Look, you can check it. We are dealing with the A is the first quadrant, so A, everything is positive. B is the fourth quadrant, so in the fourth quadrant Y is negative. In the third quadrant, both of them is negative. Plus plus, minus plus, plus minus. So as you see that over here in the fourth quadrant, this is negative. In the third quadrant, this is negative. So yeah, check. So now we're going to do AX plus BX plus CX, which is 620 plus 311 minus 33331. BX plus BY plus CY is equal to 0 minus 311 minus 439. All right. So what is it? 620 plus 311 minus 331. 600 what? 311 plus 439, and that is 750. Don't forget negative. I don't know whether that is right. So okay, so we have a right angle triangle now. So R is 600 square plus negative 750 square. We'll find out in a second. 600 square plus 750 square, and that is 960. Okay, 960 kilometer. Okay, angle tangent inverse negative 750 divided by 600. divide by what? Tangent negative 750 divided by 600, and that is a negative 51. So that is negative 51. So what is angle? 360 minus 51, 309. So 360 at 309 degree. But some of you wrote negative 51. I'm okay. For problem number 4. So problem 4 is the same problem we did in the class. You kick a ball 20 meters per second at 37-degree angle. So that directly came from the problem we solved in the class. I asked you to find the range. But the problem is you cannot use the range equation. Do we have where's the calculator? So I need the calculator because we have to solve a quadratic using the quadratic formula. Okay, so what happened is a punter kick a ball with so this is how a punter kick a ball. So kick a ball with moving up the foot from 1 meter above the ground. So 1 meter above the ground. So here is the punter foot. So punter kick the ball from here, and the ball land over there. So this is not land to land. Land to land. No. So you cannot use the range equation. You cannot use the range equation. Okay. So now, but it's easy. You don't have to use the range equation. The punter kicked the ball 20 meters per second at 37-degree angle. I just changes the problem, the one we did in the classroom. I changes a little bit because to see whether you paid attention when I said the range equation only works when you do kick from land to land. Some of you use the range equation and it doesn't give you the exact answer. So this you cannot use the range equation. If it was land to land, yes, you can use the range equation. Okay. Anyway, velocity has two components, vx and vy. 20 cosine 37, which is 16, and 20 sine 37, which is 12. So you have d is equal to vit plus half at squared. We want to find the time, so we care about the y direction only. Y direction -1, 12 minus 5 t squared, because half times gravity is -5. So 5t squared minus 12t minus 1 is equal to 0. So minus b plus minus b squared minus 4ac over 2a. So you have 12 plus minus 144, 4 times -4 times 5 times c is -1. So you have 12 plus minus 144, 154, 164. So you square root of 164. 12.8. So 12 plus minus 12.8. Don't forget divide by 2a. A is 5, so 10. So plus 12, 24.8 divided by 10. So you want to divide by 10, you want to say 2.48. Okay, 2.48. 2.48 second. All right, so now you're going to find the range use the range equation. This is the range equation. Vx t. Vx is 16 and t is 2.48. So times 16 and that gives us 39, about 40. So 39.7 meter. This one gonna give you 38. This one will give you 38. So this is the root. So you have to solve the problem this way, and that takes us problem number 5. Problem 5 is also we solve it in the class. It's the very easy problem. 3 car moves to the same direction from east to west. Okay, so car one, we're gonna call U. It is moving 11 meter per second at acceleration 0, 15 meter behind from the red light. 15 meter behind from the red light. And at the red light, there is a Porsche waiting. Porsche is moving 5 meter per second square. Not as soon as red turn green, the Porsche will wait 1 more second. Because I don't know, the driver will probably get distracted. So the Porsche start waiting when t is more than 1 second. There is a Ferrari 10 meter behind the Porsche, accelerating 4 meter per second square as soon as the red turn green. They all will meet at location T. We're going to find that location T, the time at location T, and distance at that location. Oh, that shouldn't be that difficult. Let's find the equation for U. The equation for U is D1, let's call 1, car 2, car 3. Car 1 is equal to 11t minus 15, that's it. Car 2 is half 4t squared minus 10. So 2t squared minus 10. Car 3, half 5, not minus 10, t minus 1 squared. So 2.5 or 5 over 2. I like 5 over 2. I don't know why. Okay, great. I don't like sure. So D1 is equal to D2. So D1 is equal to D2. D1 is let's write D2 is equal to D1. 2t squared minus 10 is equal to 11t minus 15. So 2t squared minus 10 minus 11t plus 15. So 2t squared minus 11t plus 5 minus b plus minus b squared minus 4ac over 2a. 11 plus minus 11 squared minus 4. A is 2 and c is 5, and this is 2 times 2, 4. So this is 5 seconds. All right, now this is D2, D1. Now let's say U and this is U. Is this U? No, this is Ferrari. And this is U. And then let's say Ferrari Porsche or Porsche. Porsche is equal to U. Porsche is equal to what? 5 over 2 t minus 1 squared, and U is equal to what? 11t minus 15. So 5 over 2 t squared minus 2t plus 1 is equal to 11t minus 15. So 5 over 2 t squared minus 2 to cancel 5t plus 5 over 2 is equal to 11t minus 15. So 5 over 2t squared minus 5t plus 2.5 minus 11t plus 15. So when you solve it, t is equal to 5 seconds. So Ferrari U, Porsche U, Ferrari Porsche. So Ferrari is right here, 2t squared minus 10 is equal to Porsche is right here, 5 over 2 t minus 1 is squared. And when you solve it, t is equal to 5 seconds. Approximately, this is approximately close to 5 seconds, not exactly 5 seconds, because loss of decimal I compromise. So 5 seconds, around 5 seconds, what would be the distance? I can use any equation I want, but let's take the easiest one. D of t is equal to 11t minus 15. So d of 5 is equal to 11 times 5 minus 15. 55 minus 15, that gives us 40. 5 second, 40 meters. All three cars right here. Very close to here, not exactly at same location. Very close to. We have two problems left, 6 and 7. But I'll stop here. Part 2 I'll do separately. This is because part 2, number 1, is for students, AP students who will need to take the reasons as well. And also the tutorial is getting too long. I won't be able to upload it. Okay, so problem number 6. Okay, so let's say this is ground, which is earth. We have two rocket 1 and rocket 2. We're going to focus on rocket 1, and this is moon. The distance from earth to moon is 3.8 times 10 raised to 5 kilometers. Hopefully you see it. Which is 3.8 times 10 raised to 8 meters. Okay. You don't have to see kilometer. Meter is fine. So the rocket, the engine burns the fuel and the rocket accelerate. This is again the distance between Earth to Moon. So we need that. Okay. So the engine burns fuel for t is equal to 5 minutes, which is 300 seconds. And when the engine shuts down, right, the velocity, final velocity would be then 10 kilometer per second, which is 10,000 meter per second. So what is the acceleration from location A to B for first 5 minutes? Okay, acceleration is Vf minus Vi over delta t. So acceleration is Vf is 10,000 meter per second over 300 seconds. So 33. Let's say 34. Nice number. Meter per second square. How much distance does it move for this long? D is equal to half AT square. Half 34, 300 square. So 17, 9, 1 2 3 4 0. Let's make it, instead of 90,000, let's make it 100,000. So 17 1 point, okay, 17 1 2 3 4 5 0 2 3 4 5 0. So 1.7 times 10 raised to 1 2 3 4 5 6 meter. So 1.7 times 10 raised to 3 kilometer. So 1700 kilometer. 1700 kilometer is nothing compared to the distance from the Earth to Moon, which is 3.8, which is 4 times 10 raised to 8 kilometer. So this is nothing. So you can completely ignore that and calling this a constant velocity problem, because this is nothing. This is gonna make no difference. So treat this as constant velocity problem. That's it. It's moving 10,000 meter per second to the moon from location A to B, Earth to Moon, because this tiny 1700 kilometer is nothing. It accelerates only for 1700 meter or 5 minutes, and then remaining time it moves with constant velocity. So constant velocity covers 99% of the distance. Okay, so let's call it constant velocity problem. If it is a constant velocity problem, how long it takes from Earth to Moon? That's all you need to do. D is equal to VIT. Half AT square is no longer there. So time is D over VI. V. D is 3 times 10 raised to 8, and velocity is 10,000. So 3 times 10 raised to 8. Oh, velocity is, yeah, minus what? 1 2 3 4 4. So 3 times 10 raised to 4. What? Second. Divide by 3600. You get 11 hour. I guess, I don't know. 3 times 10 raised to 4 divided by 3600. No? Oh, 3.8. 3.8. 3.8. So 3.8 times 10 raised to 8 divided by 10,000 divided by 3600. 11 hours. So time is equal to 11 hours. So from Earth to Moon it takes 11 hours. So I'm going to write it nicely over here. So Earth time is 0 hour. I'm going to erase this one too. Okay. On the Earth, I'm going to erase everything. So for this rocket, the time is at Earth. This is Earth. This is Moon. 0 hour. The time is on the Moon. It takes 11 hours. So this must be 5.5 hours. Half the Moon. Half the distance is going to take 5.5. Now, when it's half the way, the pilot realized, the captain realized that he left the camera. Astronaut realized that they left the camera. So they informed NASA to send the camera with the other rocket. Other rocket can accelerate 3 meters per second square from Earth to Moon. Okay. So how much before the rocket 2, this is rocket 2, will land on Moon than rocket 1? That's what I ask you. So this is very easy now. D is equal to half AT square. T square is equal to 2D over A. So 2 times 3.8 times 10 raised to 8 meter. Acceleration is 3. So T square. So this is going to give you 2 times 3.8, 7.6 divided by 3, 2.5 times 10 raised to 8. You square root it. 2.5 times 10 raised to 8. You square root it. And then you get 15811 divided by 3600. You get 4.5 hour. So this is 4.5 hour. So this one takes how long? So this is gonna get a little technical. This time, their time over here is 0 hour. Time over 4.5 hour. And this one will take remaining 5.5 hours. So 5.5 minus 4.5 is 1 hour. So this one will arrive 1 hour before rocket 1. Okay, so next rocket problem. The last one is very easy. It's like a parabola problem. Problem 7. It's kind of a parabola problem. Let's see. Yeah, it is like this. So the rocket is, you will see what I mean. Rocket is here, and then here, and then at max height, and then it's going to descend. Why is that? So when rocket here, with velocity initial is 0, but acceleration is 30 meters per second square, right? It's shooting up. It can accelerate 2 seconds only. Okay, it accelerates 2 seconds, right? Then it's going to go to the max height when velocity finally is 0. Then it deploys the parachute. Okay, at the max height it deploys the parachute, and the parachute will let the rocket descend. So it's going to make a parabola. That's why I said the parabola. So max height Vf is equal to 0. Okay, so you can think this one like this. So very important to see the parabola over here. Okay, so I want you to find what is the engine speed. Very easy. Vf is equal to, number 1, Vf is equal to Vi plus At. This is 0. Vf is equal to A is 30, T is 2. So Vf is 60 meters per second. That's the engine velocity, engine speed. That's how engine moving up. And this 30 meters per second, the engine can accelerate 40 meters per second squared. 40 minus 10, 30. So when I say that it is acceleration is 30, that means net acceleration. Okay. Now the next thing you're gonna find the max height. What is the max height? So to go to the max height, the first 2 seconds, it cover how much? Oh, let's see. D is equal to half At square. D is equal to half 34, 2 square. So half 34, so 2, 60 meters. First 2 seconds, it covers 60 meters. Now we're gonna see how much from here to here. To find here to here, we have to find Vf square is equal to Vi square plus 280. And max height velocity is 0. We said it many times. Vi is how much? 60 square. Okay, and you have to understand this one. At max height, when the acceleration, when the engine shuts down, then there is no acceleration. The acceleration A no longer there, it becomes Z. Okay, the engine is no longer there, so it becomes G. So this is negative 2 times 10D. So D is equal to 60 square over 20. So 36, 0, 0, 20, so 180. So you're gonna write 180. So 60 plus 180, so what is the max height? 240. So max height is 240 meters. The time it takes to get the max height. Okay, meaning that I ask you this time, not only this time, okay, but let's find the missing time. VF is equal to VI plus AT. All right. T is, VF is how much? 60. And A is 10. So 6 seconds. If you write 6 seconds, some of you did, that's wrong. 6 seconds is from here to here. So 6 plus 2. The max height, the time it takes from the rocket go from here to max height is 8 seconds. All right, once again, this is the end of AP Physics 1, Exam 4, Part 1.